Hello, we're here for the Chapter 5 Test Study Guide. Very exciting stuff. So we're just going to dive into the study guide. We're going to start with number 1. So simplify the identity completely. Make sure to show all work. You need to make sure you're showing all work and work that makes sense. So first thing I'm going to do here, so these are being multiplied together. So I have to recognize that I've got to simplify those first before I can do any part of the minus 1. So I would rewrite everything then to simplify everything in terms of sine and cosine. So that would be 1 over sine squared x times, and then tangent is sine squared x over cosine squared x. Okay, so at that point, then I'm thinking, okay, how can I simplify again just within here, and then we'll deal with the minus 1 after. So I can simplify this by canceling out the signs, and then I have 1 over cosine squared x. Oops, that was a different blue. 1 over cosine squared x minus 1. Now at this point, if you want, you can get a common denominator. You can get a common denominator here. But what I did was I thought about, okay, well, 1 over cosine squared is actually secant squared. And I thought that's one of my identities. So I went to my identity sheet. I looked at my Pythagorean identities, and I went specifically for this one. So tangent squared theta plus 1 equals secant squared theta. So I'm just going to write that one on the side. Tangent squared theta plus 1 equals secant squared theta. So remember, I want this to look like this. So I'm going to move the 1 over, and I have tangent squared theta equals secant squared theta minus 1. And now I can substitute in for this whole thing. I can substitute in tangent squared theta. And that would be my final answer. Now, again, if you guys wanted to instead get a common denominator here, you can and multiply this one by cosine over cosine, and then you'd have sine squared over cosine squared, which eventually simplifies to be tangent squared. So there's not one right way of doing this, but again, it's just you gotta show your work and make sense. Okay, so number 2 says simplify the identity completely. Make sure to show all work. We know that. Okay, so first thing I'm always going to deal with are these cofunction identities. So I'm looking for sine of pi over 2 minus theta. So sine of pi over 2 minus theta is equal to cosine theta. So I can simplify this out to be cosine theta. And then what I would do is just think, okay, let's rewrite everything in terms of sine and cosine. So cosecant is 1 over sine theta, and then cosine theta. And really that's over 1 if it helps you to think about that. And then we can just multiply. So when I multiply, that becomes cosine theta over sine theta. And we know that cosine over sine is the same as cotangent theta. Okay, let's move on to 3. So 3, my first thought is to multiply this out. Do you have to multiply it out to start? No, you could simplify within each parentheses first. It really doesn't matter, but I just started to multiply it out first. That's what makes the most sense to me. So when I multiply that out, okay, so remember, when we multiply, we are doing sine times tangent, so sine x times tangent x, and then sine times negative secant, so that would be negative sine x times secant x, and then we move to the 1. So that would be 1 times tangent, so plus tangent x, and then 1 times negative secant, so negative secant x. So again, very similar to what I was talking about up on 1. These are things that are being multiplied together. So we've got to simplify within those first before we can do anything. So basically, I would start to rewrite those in terms of sine and cosine. I'm going to rewrite everything in terms of sine and cosine. So I have sine x times, and tangent is sine over cosine. And then again, I'm just going to write this one over 1 so we can see that. And then minus, so sine x times secant, so that's going to be 1 over cosine x. Again, I'm just going to write that over 1. I guess I should have, to stay consistent, made those both pink, but here we are. And then plus, so tangent is sine over cosine. And then secant is 1 over cosine. Okay, so then at that point, we start to see what we can simplify. So within here, I think, okay, sine x times sine x is sine squared x all over cosine x minus, and then here is just sine x over cosine x plus, nothing to simplify here, sine x and cosine x, and then minus, again, nothing to simplify here. Now I see within my, like, now that my parentheses are simplified, I look at my whole equation and see, is there anything that can be canceled out? And there is. I have a negative sine over cosine x and a positive sine over cosine x, and those are going to cancel out to be equal to 0. Remember, when you're adding and subtracting the same thing, they cancel out to be 0. When you're multiplying and everything cancels out, that's when it equals 1. Okay, so let's move our work up here. So then I have sine squared x all over cosine x minus 1 over cosine x. And now I have a common denominator, so I can write it as a singular fraction, sine squared x minus 1 all over cosine x. And hopefully, I know that at this point we've gotten pretty familiar with this identity, but that identity is my Pythagorean identity, my main Pythagorean identity. So that's thinking about sine squared theta plus cosine squared theta equals 1. And so again, we're rewriting this to look like this. So we're moving the sign over. And what's going to happen is I can simplify this whole thing to be cosine squared x. And so I have cosine squared x all over cosine. I have 2 cosines on top, 1 cosine on bottom, so 1 can cancel on top and bottom, and I'm left with just a regular cosine x. And I'm just realizing that I made a mistake, didn't I? And hopefully you were thinking about that. Let's fix my mistake. Hopefully you're seeing my mistake and we're going to fix it. Okay, so this is not this, is it? I got too excited and too happy about it. So let's rewrite our thoughts here. Okay, so what did I do wrong? Very common mistake that I see a lot of people do wrong. Okay, so here we are. We want it to be sine squared x minus 1. Now the sign is what's positive. When I moved it over here, I made the sign negative. So that's where it gets you. So when in fact we want the 1 to be negative. So I'm going to move the 1 over here, and that's going to be sine squared theta minus 1 plus cosine squared theta equals now 0. So we moved the 1 over. And now, okay, because I just want this part, I'm going to move the cosine to the other side. And what happens, and why this is not 100% correct, is because when I move the cosine over, it becomes negative cosine squared theta. And so what I should have been replacing, oh, look at that. What I should have been replacing here was actually negative cosine squared x, and that would have made the whole thing negative cosine x. Ooh, sorry about that. Glad I caught myself. Glad it's all in video too. So, okay, here we go. Okay, let's look at 4. 4 is kind of a doozy, but we'll get through it together. Okay, so first thing I would do is use my even and odd identities. And so secant of negative x, looking here, so secant, it just turns into a regular secant. So I have 1 plus regular secant x. And then I'm actually also, instead of writing this as a like fraction, I'm going to write it as a division problem. It just helps me to kind of start to see stuff, and then really then I just am focusing on the top by itself and then on the bottom on it by itself and thinking, okay, then what can I cancel? Okay, so then we're going to go divided. So instead of a fraction, we're going to make this a division problem. And then sine of negative x, the negative comes in front, so it'd be negative sine x. And then with tangent of negative, the negative also comes in front. So instead of plus, I'm just going to make it minus tangent x. Okay, so first thing I think, I'm going to ignore my right side for now. I'm just going to deal with my left side, and I'm going to essentially just turn it into a singular fraction. So I'm first just going to rewrite everything in terms of cosine and sine. So 1 plus 1 over cosine. And then because, okay, this is like 2 separate fractions, I want to make it into 1. So again, I'm just dealing with this side. I'm going to get it to be a common denominator. The common denominator between 1 and cosine is just cosine. And so that would be cosine x all over cosine x plus 1 over cosine x. And now that they have that common denominator, I can write it as a singular fraction. So I have cosine x plus 1 all over cosine x. Okay. So essentially, there's not much more I can do with the left-hand side. There's nothing I can cancel. I've written it as one singular fraction. Everything is in terms of sine and cosine. So now I'm just going to move over to the right side. So I have negative sine x minus, and then tangent is sine x over cosine x. So I'm going to actually do the same thing, like the same idea, and combine it so it's one singular fraction. So I'm going to get a common denominator. So my common denominator between 1 and cosine is cosine. And so that would be negative sine x times cosine x all over cosine x minus sine x over cosine x. Okay, and now that is a singular, now that has a common denominator, I can write it as a singular fraction. So that would be negative sine x times cosine x. This is one singular term minus sine x. This is another singular term all over cosine x. So, okay, let's just do like a little side thought here. So if I had, I'm going to write it down here. If I have negative xy, x being sine, y being cosine, minus x, x again being sine, what could I do to simplify? Well, we could factor out a GCF. You could factor out an x, or actually what I would factor out is a negative x. Whenever like the value in front is negative, I would factor out the negative sign as well. So if I factored out a negative x, that would be y, regular y, because the negative x is now on the outside. And then negative x divided by negative x would get me plus 1. And that's exactly what we're going to do here. So we're going to factor out a negative sign, because that's the x. And then that's going to be cosine x plus 1. Still all over cosine x. So I just like kind of used this here to help me to think about how I could factor out a GCF. Okay, so now let's look at both sides put together, because now let's see if there's anything I can cancel. Okay, so now I have a singular fraction on the left, a singular fraction on the right, so I'm going to flip and multiply. So my left side's going to stay as is, cosine x plus 1 all over cosine x. And then my other side is going to flip. So it's going to be times cosine x on top, and then negative sine x times cosine x plus 1. And this is where, the fun part comes, because we can cancel. So I can cancel this cosine and cosine. Yay. And I can actually cancel the cosine x plus 1 and the cosine x plus 1. And so I have 1 over negative sine x to get me negative cosecant x. That was a fun one. I know. What a thrill. Okay, let's continue on this fun, exciting identity path. We only have 5 and 6, and then no more identities, I think. I don't know. I haven't looked. Okay, so let's look here. So first thing I'm recognizing is I have 2 things being multiplied together. So I've got to simplify that first. But I'm just going to right now write everything in terms of sine and cosine. So secant is 1 over cosine. And then sine is sine theta over 1. And tangent is sine theta over cosine theta. So again, I've got to simplify my 2 things that are multiplying together before I can start to cancel or add or do anything like that. So sine times sine is just sine squared theta all over cosine theta. And then I have 1 over cosine theta. And now we have a common denominator. And so I can write it as a singular fraction. So that's going to be 1 minus sine squared theta all over cosine theta. And this is turning in really similar to the one that I made a mistake on. So let's not make a mistake on this one. So this is my Pythagorean identity. So I have sine squared theta plus cosine squared theta equals 1. The 1 in this case is positive. The sign in this case is negative. So I'm going to move the sign over. This is what I was doing before. 1 minus sine squared theta. So I have 1 minus sine squared. 1 minus sine squared. I can substitute in. And so I'm going to move my work up here. I have cosine squared theta all over cosine. So now I have a cosine 2 on top, 1 on bottom, and I'm going to be left with a regular cosine theta. Whew, okay. Let's get to 6. Okay, so in 6, we are going to, I would, if you want, rewrite it as a, separate fraction, but yeah, I'll do that to start. So, but I'm also just going to multiply out the top as my first step as well. So that's going to be cosecant times cosecant. So cosecant squared x. Cosecant times positive 1 is cosecant x. Negative 1 times cosecant is negative cosecant x. And negative 1 times positive 1 is negative 1. And then divided by cotangent x. Okay, so all I did was just separate it out. And you're going to see why I'm a little hesitant on separating it out. But you can do that. That's to stay consistent, that's what I would do. Okay, so first thing I'm going to do is I'm just going to deal with the left side of this and simplify that. So cosecant minus cosecant, well, that goes away. And so then I'm just left with cosecant squared x minus 1. And I think, okay, is that one of my identities? And I look at my Pythagorean identity. I'm just going to write the one that has cosecant in it on the side. So that's 1 plus cotangent squared equals cosecant. So 1 plus cotangent squared theta equals cosecant squared theta. So the cosecant is positive. This is positive. And then I'm going to move the 1 over. So it's going to be cotangent squared theta equals cosecant squared theta minus 1. And now I can substitute in this whole thing with cotangent squared theta. And that's why I was like, oh, I don't really have to do anything because what ends up happening is we have, I'm just gonna write it over here so you can see it, cotangent squared x over cotangent x. So I have 2 on top, 1 on bottom. 1 is going to cancel on top, 1's going to cancel on bottom, and I'm left with just a regular cotangent x. And that is my answer for 6. Okay, let's pause the video here. That's my identities, and then I'll pick up on the other video for the other section. Okay.